Okay, we're going to take a quick look at homework for Physics of the Universe, Unit 1, number 29 through 32. Starting off, we have a block that is moving at constant velocity, and we're supposed to draw a free body diagram. So the first couple forces that we know are going on, well, first of all, we have a pushing force, but since we know it's moving at constant velocity, there must be some sort of opposing force that is keeping us at constant velocity, otherwise we would be accelerating. So that force must be friction. So there's a friction force acting against the pushing force. We have two additional forces. We have the gravitational force of the block down and the normal force pushing up on the block as well. We don't have any motion in the vertical direction. We'd say the sum of the forces in the x direction is 0 because we're moving at constant velocity, but we'd also say that the sum of the forces in the y direction is 0. We call this dynamic equilibrium because the object is moving but it's not accelerating. Problem number 30 says a ball on the back of a wagon is moving at the same velocity as the wagon initially. The wagon then hits a curb and stops quickly. What happens to the ball? Well, you probably are familiar with what would happen. The wagon is stopped because some force hits the wagon to get it to stop, but the ball keeps on rolling. As we say, a body in motion remains in motion unless acted upon by an outside force. So once the ball hits the other end of the wagon, then it is going to bounce around and come to a stop as well. But in the meantime, it will keep on going. Number 31, a box weighing 40 newtons is suspended by two vertical ropes. Draw the free body diagram. So I like to typically draw what is happening with the scenarios. We have this block that is hanging by some ropes, and then we isolate the box and we draw the forces on it. So we have a gravitational force going down, which is 40 newtons. We have two tension forces going up. We'll call each of those F sub t for tension force. And we're going to decide that we're going to define up as our positive for our frame of reference. So then when I'm going to say the sum of the forces in the y direction is 0. So the two forces acting up are Ft, the first two Ft's minus the gravitational force. And then we can solve to find out what Ft is by isolating that variable to find that the tension force is 20 newtons, which makes sense, right? It's 40 newtons coming down, then each rope is going to be pulling up with 20 newtons. But that's how you systematically go through it, drawing a free body diagram, summing up the forces, writing out the algebraic equation, and then solving it. And finally, number 32, how does a field force differ from a contact force? Give two examples. A field force is an action at a distance force. Two things could be far away from each other and you still feel and have an effect on each other. So gravitational forces, electricity forces, magnetic forces are all examples of field forces. Contact forces are things like pushes and pulls. Friction is a contact force, and the normal force, that perpendicular force, is also a contact force. So if you have a block, remember that the block is resting on a table, then there's going to be a force pushing up by the table on the block, and that is a normal force. And that concludes our homework.